Imagine you're starting a brand new AI project. Your notebook pages are filled with exciting ideas: user accounts, AI chat, knowledge search, file uploads, beautiful dashboards, dozens of features waiting to be built. Faced with that massive list, almost every beginner asks the exact same question: which feature should I build first? But jumping straight into building isolated features creates a major problem. It's like trying to build a body by manufacturing an arm, a leg, and a head, only to realize that when they are tossed into a lifeless pile, they can't actually communicate with each other. Experienced engineers ignore the feature list initially. Instead, they ask two highly specific questions. Can the core system even run? And now that it runs, are we moving in the right technical direction? Building a successful system requires establishing a fully connected body before you can teach it how to move. This approach prioritizes the health and connection of the entire system over the completion of any single isolated feature. This brings us to the first engineering concept: the walking skeleton. This is the smallest possible version of your application. Not a tiny feature, but the smallest complete system. Imagine an AI platform where absolutely no intelligent logic exists yet. A user sends a message, and the response is simply, "Hello, world." There are no chat histories, no customer profiles, and no interface. We just have a front end, a back end, and a database. But something vital exists here. Every major architectural layer is connected, with data flowing smoothly from one end to the other. By proving the application can run, that the system stands up on its own, the engineering team has removed the structural uncertainty that often stalls a project. They know the pieces fit together. A walking skeleton delivers no value to the end user. Its only purpose is to establish a working foundation so the team can actually begin engineering. So now that the structural body exists, the next question becomes, can the system actually perform meaningful work? Can we teach it to take a deliberate step? To answer that, engineers use tracer bullet development. Instead of building 5 features at once, they choose one single important end-to-end workflow to build through that established architecture. Executing this single workflow forces the system to confront reality. It tests the technical direction against actual constraints, like external APIs or database limits, rather than relying on initial assumptions. When a tracer bullet succeeds, it proves the technical direction is correct, removing directional uncertainty and readying the system for the next workflow. The walking skeleton provides the structure needed to stand, while tracer bullet development offers the feedback required to start moving. This methodology functions as a continuous cycle of discovery, driven by real-world feedback. Engineers shoot one tracer bullet, observe where it lands, adjust based on reality, and select the next workflow to expand. This builds confidence before the project becomes expensive. The method divides confidence into 2 pillars. The skeleton secures architecture, and tracer bullets secure engineering decisions. Whenever you begin a new project, resist the instinct to build a pile of isolated features. Build the smallest system that can run, and let reality dictate every subsequent step.